You know, we use the internet every single second of our lives, but have you ever stopped and really thought about what happens when you click something? I mean, how does that one simple action connect you to a server maybe halfway across the world and do it instantly? Well, today we're going to pull back the curtain on that invisible, high-speed digital journey.
I absolutely love this quote from Dave Barry. It just perfectly captures how magical and, let's be honest, how totally bizarre the internet can seem. That weird kazoo noise he's talking about, that was the sound of a dial-up modem. And for a lot of us, it was the gateway to a whole new world. But what's really going on behind all that noise?
It is so easy to forget that not too long ago, sharing data meant physically walking it over to another computer on a floppy disk. Yeah, we actually called it sneakernet. To go from that to a world where data crosses continents in less time than it takes you to blink, well, that leap isn't just big, it's almost unbelievable.
So how in the world do we even begin to make sense of this incredible leap? Well, the best way to do it is to follow the journey of just a single piece of data. We're going to trace its path from the moment you click, all the way out into the big wide world, and then all the way back again.
And the hero of our story is going to be something super simple, a single like. The second you click that little button, you kick off this invisible, globe-spanning adventure. So come on, let's follow our data packet.
So, our package journey begins right where you are, in your own digital home base. Because here's the thing, before that data can travel the world, it first has to learn how to navigate its own neighborhood.
And that digital neighborhood, it's called a local area network, or what we call a LAN. This is your private, trusted network. It's made up of all the connected devices you have in your home or your office. You should think of it as the starting block for any piece of information that you send out.
Just think about all the stuff you have connected to your Wi-Fi right now. You've got your laptop, your phone, maybe a smart TV, a printer, a game console. They are all part of the same team. Every single one of them a member of your personal LAN, and they all need a way to talk to each other.
The little piece of hardware that makes all this local communication possible is called a switch. A lot of the time, it's just built right into your Wi-Fi router, and a switch acts kind of like the local mail sorter for your LAN. So when you send a document to print, the switch is what makes sure it goes to the printer and not, to your PlayStation by mistake. It expertly handles all that local traffic. Okay, so our little packet is ready to leave your computer. But it can't just wander out onto the internet unprepared, right? It needs to be properly packaged and addressed for its big trip.
And that brings up a really crucial question. How does one tiny packet of data among literally trillions of others flying around know exactly where in the world it's supposed to go? And how does it get there without getting lost?
Well, the answer is actually pretty familiar. It works almost exactly like a global postal service. Your data needs to be put into an envelope, it needs to be sealed up for security, and it needs a precise address stamped right on the front.
This whole process works in layers. So first, you have the data itself. That's our like. Then, a set of rules called TCP wraps it up in a secure package, kind of like an envelope. And finally, another set of rules, IP, slaps that destination address on the front. This whole process of wrapping data up in layers, it's called encapsulation.
So let's look at that first layer, TCP. This is basically the rulebook that guarantees your data arrives safely. If a packet gets lost somewhere along the way, TCP is smart enough to notice it's missing and it just sends a replacement. It's literally the certified mail service of the internet, making sure nothing gets lost or scrambled. And next up is the Internet Protocol, or IP. Now, every single device connected to the internet has its own unique IP address. This protocol is what gives our like packet its global shipping address. It's the reason every network it passes through knows exactly where to send it next. It's like a universal zip code system for the entire planet. All right, let's recap. Our packet is now packaged up with TCP, it's been addressed with IP, and the switch just handled it. It is officially ready to leave home and begin its journey on the open road. And the device that makes this leap possible is the router. The router is the gateway between your private little local area network and the massive public network outside. It reads the IP address on your packet and basically says, okay, you're not going to the printer down the hall, you're going out into the world, and it sends it on its way.
And this right here is the key moment. Our packet started its life on the LAN, that small private network in your house connected by a switch. But now, thanks to the router, it's heading out onto the WAN, a global network connected by a massive worldwide infrastructure.
A wide area network, or WAN, is just any network that spans a large geographical area.
And the biggest, most complex, most incredible WAN on the entire planet is, of course, the Internet itself. This is the superhighway our little like packet is now traveling on.
So, we've covered all the key players, we've covered the protocols, now let's put it all together. Let's watch the entire incredible journey of our like from the very beginning to the very end. Okay, here it is. You click like. Your computer packages that click with TCP and IP. The switch directs it to your router. The router then launches it out onto the Internet, the WAN. That little packet zips across cities, under oceans, handed off from router to router until it finally reaches its destination server. And then, and this part is just amazing, that server sends a tiny confirmation packet all the way back to you, reversing the entire journey just to turn that little like button blue on your screen.
And that whole round trip, your click, the journey to the server, and the journey all the way back, that happens trillions of times every single day. It is an invisible, constant, high-speed conversation that connects every single corner of the globe.
And here's the craziest part. It all happens in a fraction of a second. This mind-bogglingly complex system of local networks, global connections, and digital languages works so flawlessly that we don't even notice it's there. It really makes you wonder, if we can do all of this today, what will this invisible, instantaneous world make possible for us tomorrow?